So today, in addition to actually uploading an example program for you showing how I would complete uh, the requirements of the time and event sequencing assignment, I decided I'd kind of do a video that showed you how I write my program and how I plan out the program, how I would think through it. And the more experienced you get at programming, the less you might need to do each of these steps. For example, in all these assignments, when I'm creating an example program for you guys, so far I wouldn't have gone through these formal steps that I'm going to go through here today, but they might be helpful to you as you're planning out each of your programs, and especially as you get into the final project, which is probably the most complicated program that you'll have attempted yet. I thought it might be helpful just to kind of have some advice about how I would go about when I'm first setting up the program. So on the left pane here, you can see I have the assignment functional description, I would just call it, where I tell you what I want it to do. And on the right, I just have a blank page where I'm going to start my notes and laying out my inputs, outputs, phases, things like that. So let's go ahead and get started. So the first step I would do is read through the functional description at least once, probably more, so that it kind of starts sinking in what my goal is here. So today's challenge is to, on power up of the PLC, it should wait for a press of the OK LCD button. So in my head right now, I'm thinking, okay, there's my first input that I need to be accounting for in my program. It's going to be the OK button. Okay, moving on with the description. While waiting, it should display waiting on line 1. So you could think of that as an output. You're going to have line 1 of your LCD that you're going to need to control as an output, as something that's communicating information or performing some function in the actual world. Okay, so when OK is pressed, line 1 should change to display flash, and the green and red light should begin flashing on and off for 500 milliseconds each. So right there I have two more outputs now that I should be keeping in my mind. I'm going to need to control the green and red lights. This flash state should continue for 5 seconds. After the 5 seconds, the lamps should both turn off and line 1 display restart. It should remain with all lamps off and restart on line 1 until the red button is pressed. Okay, there's another input that I'm going to use, the red button. When the red button is pressed, the program should increment a counter by 1 and returns to the original waiting state until the OK button is pressed again and the cycle repeats. The value of the counter should be displayed on line 4. Okay, there's another output, basically, line 4. It keeps track of how many times the machine has run through the cycle. So if this were me, if I were actually doing this process, I would be writing my inputs and outputs down on a piece of paper as I went along. But since my handwriting isn't that great and using the DocCam isn't very clear, I thought I would just do it in a blank Word document here. So I'm going to create a table. It's going to have inputs. We'll do, that should be enough. Okay, so I'm going to put inputs in this column and outputs in this column. And so we said our first input was the OK button on the LCD. And we also had a red push button. Okay, outputs, we have green lamp, red lamp, line 1, and line 4. Okay, that's a kind of overview of my inputs and outputs. Just to make things a little clearer here. Okay. Now I'm going to read through the description again, and this time, instead of keeping track of what inputs and outputs I'm using, now I'm going to start breaking the program down into phases. That's just how I've found it most useful to structure my programs and to think about them, especially in programs that have discrete operations going on. This is not necessarily the case if you have an application where you're programming for a process control situation where things are always going on simultaneously. You're controlling temperature and flow and concentration and pressure. Those are different. They still might be sequences, but they're just a little different. It's not a series of steps you're going through. It's more a number of processes that are happening simultaneously. So that would be a different way of structuring your program possibly, but we're focused on mainly these sequential events happening in this class. So let's look through the functional requirements again, and thinking about it in terms of phases. So I'll create another little table here. Let's just say, I don't know how many phases we'll end up with, but we'll start out with phases. Okay, so the first thing is on power up, it should wait for a press of the OK. So I'm going to call that my waiting phase. While waiting, it should display waiting. Okay, so waiting occurs on power up and displays the text waiting on line 1. So that tells me what I'm calling my phase, kind of the waiting phase, and what's supposed to happen to it. My next phase is going to be, I'll call that my flash phase. And so this, when this happens, it occurs after press of OK button. It consists of flashing red and green lamps on and off, 500 milliseconds on, off. Okay, and one other clarification, red lamp is on when green is off, and makes sense. Okay, so that's phase 2, I might think of it as, is my flash phase. And that one lasts, okay, that one lasts for, let's see, it lasts for 6 seconds. Okay, so then the next phase will be a restart phase. And it occurs, occurs when flash has been running for 6 seconds. The function of it is all lamps off, display restart, on line 1, ends when red push button is pressed. Okay, that's a decent summary of the restart phase, I think. So here, let's just talk a little bit about those. You'll notice I called this assignment time and event sequencing. And you can see when we start up, we're in waiting phase. The sequence to move on to the next, it's waiting for an OK press. That would be called an event happening. So we're moving from waiting phase to flash phase based on the press of a button. So that's an event-based sequence. However, to move from flash to restart, that happens after 6 seconds. It doesn't wait for any event. It's just a time-based sequence. So you can see first transition from wait to flash is event-based sequence. From flash to restart was a time-based. And now from restart on to wherever we're going next is again event-based. It's when the red button is pressed. Okay, so let's talk about what happens after restart. So when we hit restart, it looks to me like we're gonna, okay, so let's talk ends when red push button is pressed, And here what happens next is a count cycle. So we're going to increment a counter. And that is not really a phase by itself, right? That's something that's going to happen instantaneously. When we leave the restart phase, we want to trigger a counter and then move into our next phase. I just kind of want to distinguish between that. That counter, that's not a phase, right? It's just going to do that and be done doing it. So I'm going to put in here ends when red push button is pressed and increments counter by 1. So that's part of the restart phase. That's basically the end of the restart phase. And then where are we going? We're going back to our waiting state. So really those are our 3 phases: waiting, flashing, and restarting. And then we just go back into the waiting phase again. So that's, I think, enough summary about the phases themselves. But let's talk about how we could structure our program now based on those 3 phases. If we had a machine that had maybe 40 steps to go through, I would probably keep track of what phase I was in using a variable that had a number in it correlating to the phase. If you go back and look at the optional assignment that I showed, that I posted an example program for, there I kept track of my phase was a dent variable that had the number of the phase in it. Here, where I only have 3 phases, it hardly seems worth it to me to set up the logic for that. So this is a case where I would probably just keep track of what phase I am by having a single bit that represents the phase I'm in. So let's think about some of the programming instructions we're going to need here. Looking at the functional description, in the waiting phase, and now that we're done with the actual assignment, I'm going to zoom in a bit on this so that you guys can see what I'm typing a little more clearly. Let's see. Okay, so in the waiting phase, what am I going to need there? I'm going to need to display things on the LCD. So at a minimum, I'm going to need an LCD instruction. I'm watching the OK button, but I'm not actually using it yet. But I can see that I'm going to use it, so it makes sense right now to just make a note. I'm going to need a key read because I'm using the buttons on the LCD. I'm going to need a variable for line 1, so I'll say I'm going to need a line 1 string variable. What else? I'm not doing anything with lights. If I wanted to, it might be good practice to put in a line of code that on power up clears all my variables or sets them to be 0. In simple programs like this, I can probably do that just using the initial values. But just when you're thinking about your first phase, that might be something you think about. Okay, so let's look at the flash phase program elements. So I'm going to need the OK button press. So I've already got my key read in there. I need flashing green lamps on and off. So in my mind, that means I'm going to need a T on off timer with 500 and 500 millisecond on and off. And I'm just kind of listing the main program elements. Obviously, I'm going to have contacts and output that would be different or in addition to these, but just starting to think about the big pieces I need. I'm going to need a timer. So this T on off will give me the time for the flashing lights. I'm going to need another timer that keeps track of the 6 seconds that this phase lasts. So in my mind, that's probably going to be a on delay timer is probably what I would use there. So T on. And let's see. I think that's it for that one. So now let's look at restart phase program elements. So I can see I'm going to need another variable that's moving restart string variable, or move, at least moves that restart phrase into string. And that points out that I missed that up here. I have a line 1 string variable, but I didn't ever say that I'm going to need to move a waiting string somewhere in there. And here I'm going to need to move a, what's it called? Move the restart string. And did I not need to have it say flash on my program? I think I may have missed that. Yeah, so in this phase here, I also need it to display flash during that phase. And so I'd want to do that same thing here, move my flash string around. Okay, so those are something I missed on my first run through. And now let's finish up looking at restart. So I've moved my restart. I'm gonna need to turn off all outputs, and I'm going to need to have a counter that's counting up. So I'll have a CTU counter in there. So I think that's enough kind of how I would break down the program into inputs and outputs that I'm going to need, phases, and then kind of chunks of what I want to happen in each phase. So I'll go ahead and minimize that. And I guess actually before we go into the program, one other step that again you could totally just do as you're programming, but just to make it real clear here and help you think through as you're planning, let's just list under each phase the variables that we think we'll want for that and their data type. So in my waiting phase, I'm going to have a Boolean variable that is waiting. That's going to be basically my status bit that says, hey, I'm waiting right now. Let's see what else in here. I'm going to have a string variable that is also waiting. I'll call it waiting string, and I can either put an initial value in there, so I'll call it initial value is waiting. You could also move that value into it if you wanted later, but since we're not going to be changing it, it's fine to just put it in under the initial value. Let's see. So I think that's all the variables that jump out at me right now for the waiting phase. So now let's look at our flash phase. So here we're going to have a Boolean that's our status bit that we'll call flash. I'm going to have a string that is the flash string, and again I'll use an initial value of flash on it. I'm going to have timers in here, so I'll reference the various bits of that timer. I don't think I'm hard-coded on my time on and off, so I don't need to change that any. Those are all that come to mind right now. I guess that's not quite true. Maybe right up at the start here I would put my string variables, my line 1 string variable, and I won't put any initial value in it because I'm going to be changing what goes into that one. And I don't think I could also, I guess, right up front put in the string variable for line 4 because I know I'm going to use that later. Well, looking at that, I never finished my functional description up on phases, in that in all of these phases an increments counter by 1, which is displayed on line 4. So again, that's not really that occurrence is not a phase, but it's happening in there. Okay, so we've got our line 1, line 4. We've got Boolean for I'm in the flash versus string for there. That's fine. So now let's look at variables for the last phase. So I would have a Boolean that I'm going to call restart. Then I'll have another string that is restart string, and its initial value will be restart question mark. Okay, and let's see, I'm going to have a counter in here, but that's not a bit, that's a data type that I've already got. Okay, so I think we have enough variables. We'll probably end up adding some along the way, but again, just trying to help you think through how I would plan it out. So let's get that down a little smaller and start up Connected Components Workbench. And I will just start from scratch, although I recommend to you guys, remember to always start from a template. It just saves time, but I'm just going to show you as if we were starting from scratch. We'll create our project, select our controller, and so since I am starting from scratch, I should configure a few things, right? I should let it know that I have an LCD. I'm going to go into my create a program, a ladder diagram program. I'll call that program time and event. Okay, and now let's edit some variables based on our Word document. So if I zoom to page width, and let's look at our variables. And again, we'll probably add some, but I have a waiting Boolean, and I have a flash Boolean, and I have a restart Boolean. Okay, and then I have a wait, what I called it, waiting string. And it has an initial value of waiting. Okay, and then I have a flash string. Oops, I got messed up on that one. Let's see if it's won't let me. Let's come back. Delete that one. I accidentally selected the wrong type there, so try that again. Flash, str, and string. And this one's initial value is flash. Okay, and then we have the restart string. And restart with the question mark in there. Okay, so we've got our Booleans, we've got our string variables that are never going to change. Now let's add our line 1 string variable, which I'm not going to put an initial value in because I'm going to move values into there that I want. And line 4 will do the same thing. Okay, I think those are all the variables that jump out so far. So let's go look at our program. So let's go back and look at our functional description about what's supposed to happen when we first power up. So it looks like on power up we want to display waiting on line 1. So let's add in some of our just basic instructions we know we're going to need. So that would be LCD, and we can just leave that down at the bottom. I know I'm going to use my line 1 there, and I'm going to use my line 4 here. And these ones I'm just going to put in 2 single quotes in each one, so I'm not going to display anything. I am using the keys on the LCD, so I need to have a key read instruction in there. And I can just leave that one down there. Okay, so now when I start up, I want to be in the waiting phase. So I'm going to go back to my variable, and in waiting, on initial value, I can put either 1, that's one way of setting it, or I can type in true. Either one of those are fine initial values that will set that bit to be true when I start up. So now when I'm starting, I know that I'm going to have, oops. So let's say if waiting is true, I want to move my waiting string into line 1. So while I'm in my waiting phase, line 1 should display the waiting phrase. Okay, I stay in that until, let's go back and look at our description. So it's just going to stay there on power up. That's going to be true, and I will be displaying waiting on line 1. Then I'm going to wait until I get a press of the OK button. So I'm going to watch for a press of, that's under my key read instruction. The OK button is EKY. Okay. So when that's true, when I hit that OK button, that means I want to set my flash, right? I'm moving into the flash phase, and if that's happening, I also want to reset or set to 0 my waiting. So this is key idea. I'm transitioning out of the waiting phase into the set phase. So if I'm setting flash, I need to unset waiting. Okay, so far so good. While I'm in the flash sequence now, some things need to happen. One of them is I need to move flash to my LCD, right? Well, that's going to be really similar to what I have here on rung 1. So I'm going to select rung 1. I'm going to copy it. I'm going to come down here right before rung 3 and paste it. And that way I can just edit the address so that now instead of waiting, I say if flash is true. So now I'm in the flash phase. I want to move the flash string into line 1. Okay, so I've got the first thing. I've got my display going okay. I'm also supposed to be flashing my lamps on and off though, right? So we need to add our time on off that we talked about in our planning. So I'll put in a time on off timer, T on off, and it was on for 500 and off for 500 as well. And I need to put its own Q bit in front of it to make it cycle. So I'm just going to let that timer run all the time. And then I'm going to look at the output of it to control my lamps. So let's add a line now that's controlling my lamps. So let's create actually a bit that's flashing rather than the lamp itself. And I'll show you why in a minute. So let's create one more Boolean bit that is, I'm going to call flash light. And now I'm going to say that if I am, let's see, how do I want to control that? The best way to control flashlight would be, let's put, if I'm in the mode where I should be flashing, so that's flash, and the Q bit, so this is the one that will give me the on off to it. I want that to control the status of this bit that I called flashlight. Okay, is that, hopefully that makes sense what I'm doing there. So this bit now will turn on and off every turn on for 500 milliseconds, off for 500 milliseconds if I'm in the flash mode. And I'm doing that so that I'm only addressing the lights in one place, like I said before. So now let's put a rung where we're looking at the lights. So if flash light is true, and I'm going to put and I'm in the flash mode, then I want the green lamp to be on. And I didn't do any aliasing here yet, but green lamp is output 0. So OK. And now here's the distinction. Let's actually put flash in front of flashlight so that I can then put a branch in here. And I'm going to branch and put flashlight inside that. So now I'm going to add an opposite instruction on flashlight and put the red lamp off that. And red lamp is output 3. So let's walk through that rung, because there's kind of, so hopefully you're comfortable with the idea that flash is only going to be on when I'm in the flash mode, and then flashlight is toggling on and off on half-second increments. So by using flashlight here in the exam and if closed, I get the light on when the timer is true, and here I get the red lamp on when it's false, but neither of those will turn on unless I'm in the flash mode. If I didn't have this bit in front of it, if I just used flashlight, then in theory I could sometimes end up with the red lamp on depending on how I controlled flashlight. Actually wouldn't here because, and I guess that's true, I can leave flash off of this rung because I had it on this one. But maybe, I hope it's clear that I need to have this one either here where it is or here. I have to have some way of controlling so that that red lamp doesn't come on unless I'm in the flash mode. Okay, so that's fine. Let's download that much of it and see if it works. Okay, so you can't see the PLC. Let me share that screen if I can. No, I can't do that here. Let me pause the recording and add the screen so you can see it. Okay, so now I think it should be recording the PLC down in the corner. So if you look at it, you can see that we're displaying waiting on line 1. We don't have any lamps on yet, so let's hit the, what was it? We hit the OK push button to move forward. Okay, so it looks like that's working. We're in flash on line 1, and we're toggling back and forth between our red and green lamps. So far it looks like everything's behaving as we had hoped it would. I didn't have anything in there yet to turn things off. So before I disconnect it to edit it, I'm going to go back to my main program screen and switch to program mode, just so that the lights turning off and on aren't annoying me ticking while I'm programming. Okay, so let's go back to our program and disconnect. Looks like everything's behaving as we wanted. So we're happy through our waiting phase is working, our flash phase is working. So now what do we need to do? that is supposed to last for 6 seconds, that phase of flash. Okay, so we need to come back and add a rung that is watching that 6-second period. So I'm going to, again, I'm looking for a time that starts when I move into the flash phase. So again, I'm going to use flash, and I'm going to want it to last for 6 seconds. So I'm going to use an on delay, T on, with a time of 6 seconds. T pound 6 seconds. Okay, and once that 6 seconds has elapsed, right, after flash has been true for 6 seconds, then I want to reset flash. That's the end of my flash phase. And so if I'm moving out of flash, that means I'm going into a new phase. Oops, I need to bring the branch first. So I'm going to bring a branch down and then set my restart phase. So this is the rung that says, okay, this is a time-based sequence. If I've been in the flash mode for 6 seconds, then I want to move into the restart mode. Up here, we were an event-based, right? On rung 2, we were watching for an event to happen, a key press, and we moved then from waiting to flash. Here, now, doing time-based, in rung 6, we move from flash to restart. Okay, so what happens in restart? So when restart occurs, we want to turn all our lamps off, looks like, and display restart on line 1. Okay, so let's do that much. So I'm going to put another examine if closed for restart. And I can just copy this move instruction. And I'm moving, instead of flash now, I'm moving restart string into line 1 when I move into the restart mode. Okay, and I actually don't need to turn the lamps off in this mode, because the lamps will automatically have turned off because I'm no longer in the flash mode up here on line 5. So there's no extra logic required to do that. And that's good, because anytime it's possible, I want to keep all of my addressing of hardware outputs on just one spot. Okay, so that'll turn off the lamps, that'll display restart on line 1, and that's good for that phase. Then the next thing that's going to happen, it's going to watch for a red push button press, at which point it's going to increment the counter by 1, and that counter is displayed on line 4. Okay, so our next sequence that's going to happen is based on an event, right? A press of the red push button. So let's add a rung that we're going to look at that red push button. And you'll remember that the red push button is always on, so I'm going to use a reverse contact for it. And the red push button is input 0, I think. Okay, so when I press the red push button, what I want to have happen is reset the restart. I'm done with my restart, and I want to move back into waiting. Okay, so that'll move me from restart back into waiting, but also at the same time I want to add 1 to a counter. So I'll do that. I could do more of a branch here, which we can do that. Let's just add another branch. Oops, not there. I'll just add it on another rung to keep it cleaner. So again, with the red push button press, I'm going to add 1 count up. Okay, and I didn't say a max value, so I'll just put in 10,000. It can count up to 10,000 cycles. and reset. What do I don't really need to reset because I think I didn't tell you. Let's look back at the instructions. Don't think I said value. It basically keeps track of how many times the machine has run through the cycle. Yeah, so I never told you that it had to reset. So basically this would be a cycle counter for each time you power up the machine. Okay, so come back down. No need to reset, although just to show you how you can use it, we've talked about it but never actually use it. I want to show you we can set it so that it resets every time the program first scans. So I'm selecting under system variables the first scan bit, and so when it first runs after powering up, it'll reset the counter if there was a variable in there. In this case there won't be because we're not saving the value from one run to another. But there we go. Okay, and then I need to display that counter value on line 4. So I need to do an any to string, and the input to that is going to be my counter current value. And since I'm always displaying that on line 4, I can just hard put line 4 in there. Okay, let's try downloading that and see. I think that should do most of what we want. Okay, looking at the PLC screen, we're in our waiting mode. That's how it should power up. I hit the OK button to move into flash mode. That looks good. The light is flashing back and forth, and that should take 6 seconds. Okay, now I'm asking, should I restart? And to hit restart, I hit the red push button, right? So hit red, and I'm back in waiting. And now you can see the count, hopefully you can see there, the counter's gone up by 1. So if I hit green again, oh no, it's not green, it's okay, isn't it? Sorry. Okay, and restart by hitting red, and now the counter shows that it's gone through the cycle twice. I can hit OK again, and it'll just continue on. So I think I've created all the functionality that was required, but the good last step is always to go back and read the actual assignment again. Make sure that my planning document, I didn't forget more things than I knew I forgot there. So on power up, it should wait for a press of the OK button. While waiting, it should display waiting. We've got that. So we're waiting. That looks good. When OK is pressed, line 1 should change to flash. Yep, that's doing. And the lamps should begin flashing on and off. Red and green alternating. Well, yep, 500, 500. Oh, it says 5 seconds. I don't know where I got 6 seconds. So right there, that's an example of why you always want to go back and read the functional description exactly. So I made a mistake in my program. So let's go back there. Thankfully, these things are really easy to change in a PLC. So I need to find my timer right there and change that from 6 to 5 seconds. I'll go back and change my documentation as well. 5 seconds. Okay. And re-download that. But let's keep reading the functional instructions, functional requirements while it's downloading. Just wait till it asks me. Yep. Okay. So 5 seconds. After the 5 seconds, lamps should both turn off and line 1 display restart. That's what it was doing. When the red button is pressed, it should increment a counter by 1 and return to the original waiting state, and it repeats. Value of the counter displayed on line 4. Yep, so I'm glad we went back and read through the actual assignment. That saved me missing points for doing 6 seconds instead of 5. And let's see if it's done. And let's try it again now, see if our 5 seconds is better. Okay, and get into restart. Yes, and increment by 1, wait for OK. So it's now doing everything that the assignment required. I am not going to put in here, but I would expect you to now write out a description of what each rung does in the rung comments. I've been doing that verbally as we went along, but I hope that helps kind of walk through one way that you can plan out and create a program structure. Hope that helps. Let me know if you have any questions. Thanks.